Hello again. In this presentation, I'll be analyzing the empirical rule. The data that is presented in this presentation is the same data that is presented in presentation 1. The only difference between these two presentations is presentation 1 is more aimed towards analyzing a histogram, and this presentation is aimed more towards analyzing the empirical rule. In my presentation, I show you how to compute the mean and what that necessarily is. I show you how to compute the standard deviation and what that is. I show you how to compute the values of 1 standard deviation, 2 standard deviation, and 3 standard deviation. I show you how to get the proportions of each class within 1 standard deviation, 2 standard deviation, and 3 standard deviation. And lastly, I explain and compare the values I got from the empirical rule and the values I got from the histogram in presentation 1. Here's my presentation. Okay, so as you can see, I still have my previous data from presentation 1 because we are going to be using this in this presentation as well. So the first thing we are going to do is we are going to compute the mean. And we are going to do so by using the population mean formula, which is population mean equals all of our values added like so, and divided by the total of numbers that we have. And once I apply this formula to our data, we get 54 plus 60 plus 62 plus 62 plus 63 plus 63 plus 63 plus 64 plus 64 plus 64 plus 65 plus 65 plus 65 plus 66 plus 66 plus 66 plus 66 plus 68 plus 68 plus 68 plus 69 plus 70 plus 70 plus 70 plus 72 and plus 72, and we are going to divide this by 26, which is the total numbers we have. And when we add these values, we get 1705 divided by 26, and this gives us about 65.58. But since we are rounding to the nearest tens place, this gives us 65.6, and this mean represents average of our data. The next thing we're going to do is we are going to compute the standard deviation. Okay, we are going to compute the standard deviation using the population standard deviation formula. But before we calculate the standard deviation, we have to calculate the population variance first, which is the population variance equals our values minus the population mean squared plus our second value minus population squared plus our third value minus population squared, and so on, as you can see. And this is also going to be divided by the total numbers we have, and it's going to be square root. Now when I apply this formula to our data, I get 54 minus 65.6 squared plus 60 minus 65.6 squared plus 62 minus 65.6 squared plus 62 minus 65.6 squared plus 63 minus 65.6 squared plus 63 minus 65.6 squared plus 63 minus 65.6 squared plus 64 minus 65.6 squared plus 64 minus 65.6 squared plus 64 minus 65.6 squared plus 65 minus 65.6 squared plus 65.65.6 squared plus 65.65.6 squared plus 68 minus 65.6 squared plus 68 minus 65.6 squared plus 68 minus 65.6 squared plus 69 minus 65.6 squared plus 70 minus 65.6 squared plus 70 minus 65.6 squared plus 70 minus 65.6 squared plus 72 minus 65.6 squared and plus 72 minus 65.6 squared, and we're going to divide all of these values by 26, and when we add all of these numbers we get 390.36 divided by 26. This gives us about 15.01, but since we're also rounding this to the nearest tenths place, this gives us 15.0. So now that we have our population variance, we can go ahead and find our standard deviation, which is the square root of our population variance. So our population standard deviation will equal the square root of 15. And this equals 3.87, which equals to 3.9 when rounded to the nearest tenth. And this number right here is a measure of distance. The values are from the mean. And I'm going to circle all of our values so we have it. And I'm going to give us some more space to write because we don't have that much. Going to put this in the corner. Okay, 1 second. Okay, I'm going to put this in this little corner, and we are going to move on. Now the next thing we're going to do is I'm going to show the proportions of the class that are within 1 standard deviation, 2 standard deviation, and 3 standard deviation. So I'm going to zoom in a little bit so you can see more clearly. And now we are going to compute 1 standard deviation, and we are going to do so by using the formula population mean minus the standard deviation, and this will give us 65.6, which is our population mean, minus 3.9, which is our standard deviation, and this gives us 61.5. Now we're going to do the opposite and do addition. So this will give us 65.6 plus 3.9, and this gives us 69.5. So now we are going to compute our second standard deviation. And we are going to use the same formula, but we are going to multiply our standard deviation by 2. This gives us 65.6 minus 3.9 times 2. And this gives us 57.8, Then we're going to do the opposite and add. Multiply by 2. This gives us 65.6 plus 3.9 times 2. This gives us 73.4. Now we are going to compute third standard deviation. Which is also similar, but we are just going to multiply our standard deviation by 3 now. This gives us 65.6 minus 3.9 times 3. This gives us 54. And now we're going to do the opposite and add these numbers. This gives us 65.6 plus 3.9 times 3. And this gives us 77.3. So now that I have computed our first standard deviation, second standard deviation, and third standard deviation, we're going to apply this to the empirical rule. So I'm going to put this in its own corner as well. And I'm going to draw my empirical rule in this corner. And I'm going to start off by drawing the shape. I should redo the shape to make sure it's even all around. Sorry about that, I'm really bad at drawing. Okay, this is as best as it's gonna get. Okay, so now I'm just going to complete the drawing. Okay, so the middle point is always going to be the mean, which is 65.6. This is the mean. Now I'm going to start from the right. I'm going to change my color to, let's do pink. Okay. So as you can see, our first standard deviation for subtraction is 61.5. So this means to the left. So I'm going to go 61.5 to the left and 69.5 to the left. And then I'm going to change my color for the second standard deviation to, let's do purple. And as you can see, to the left is 57.8. So I'm going to write that, 57.8. And addition is 73.4, which is the right. Then I'm going to change my color again for the third standard deviation. And as you can see, the subtraction is 54, which is to the left. And the addition is to the right, and this is 77.3. Now I'm going to go back to my pink to show that this is 68%. My purple to show 95%. And lastly, 99.7%. So this is my empirical rule applied. And as you can see, the values from the empirical rule show that 68% of the 26 members in the class are between 61.5 inches and 69.5 inches. 95% of the 26 members of the class is between 57.8 inches and 73.4 inches. And lastly, 99.7 of the 26 members in the class are between 54 inches and 77.3 inches tall. Now, the data we have here on the empirical rule is similar to the data from the histogram, because if you add the heights, let's say from 61 to 61 to 69, we have 62, 63, 63, 63, 63, 64, 64, 64, 65, 65, 65, 66, 66, 66, 66, 68, 68, 68, and 69. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is 19 out of the total number 26. And this gives us about 73%. As you can see, 68%, 73% are very close. So that is similar. And now we are going to do, let me pick a different color. Let me do a red. Actually, we'll do a red. And now we're going to do 95%. So 95% is from 57.8 to 73.5, and those numbers would be from 57, that would be 60, 62, 62, 63, 63, 63, 64, 64, 64, 65, 65, 65, 66, 66, 66, 66, 68, 68, 68, 69, 70, 70, 70, 72, and 72. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now this is 25 out of 26, which is about 96%. And as you can see, 95 and 96 are very similar again. So now I'm going to pick a different color. We can do blue. And I'm going to do 99.7%. And that is the height from 54 inches to 77.3. And as you can see, our lowest number is 54, and our highest number is 72, which is between both these numbers, so it would be all the numbers. It would be 54, 60, 62, 62, 63, 63, 63, 64, 64, 64, 65, 65, 65, 66, 66, 66, 66, 68, 68, 68, 69, 70, 70, 70, 72, and 72. And these are all 26 numbers, so 26 out of 26. And this is 100%. And this is very similar to 99.7%. So as you can see, each percent are very close rather than different. All these percents are very close. So therefore, the data is very similar to the histogram. I hope you enjoyed my presentation, and I hope I was able to give a clear explanation of what empirical rule is and the steps of analyzing empirical rule. Just to give a quick review before I end my presentation, I just want to give a little explanation on the requirements of empirical rule and what the data in empirical rule necessarily means. So as for the requirements, the only requirement for empirical rule is the distribution must be both shapes. As for the data represents 68% of the data lies within 1 standard deviation, 95% of the data lies within 2 standard deviation, and 99.7% of the data lies within 3 standard deviation. Again, I hope you enjoyed my presentation, and I hope I was able to get across my points and really analyze what empirical rule is. Thank you.